Today we're going to talk about the antiderivative and overall get an introduction to integration. So the antiderivative is essentially the reverse of the derivative. So this point in your calculus class, you should have already learned how to do the power rule when applying derivatives, which is as follows. The derivative of x to the n power is equal to n times x to the n minus 1 power. So you bring down the n and then you subtract 1 from it, right? Today I'm going to teach you guys a formula for basic integration called the reverse power rule. And this one goes as follows. The antiderivative of x to the n power dx is equal to x to the n plus 1 over n plus 1. So now that I've given you guys the formula that you're going to need to do basic integration, let's do some practice problems. So the first problem wants us to find the antiderivative of 5x to the 6th power. So we're going to apply this formula that we learned in the beginning of the video, and we're going to find the antiderivative. So we're going to rewrite 5x to the 6 plus 1 over 6 plus 1. And then we're going to simplify this. So we're going to get that this is equal to 5x to the 7th power over 7. So now I know that the integral of 5x to the 6th power dx is equal to 5 over 7 x to the 7th power. Now, when applying the antiderivative, there are infinitely many solutions. Here's why. At the end of every single antiderivative, you always need to add a plus c. Now here's why. C is a constant, right? And the derivative of a constant is 0. And there can be infinity many constants because you can have 1, a 2, a 3, and so on. But the derivative of that constant will always be 0. Therefore, when you do the derivative of this function right here, you will always get 5x to the 6, regardless of whatever constant you have right here. So you always need to add a plus c at the end. Let's do another problem. This problem wants us to find the antiderivative of the following function, 2x to the 1/3 power. So in this problem, the exponent is a fraction. But that isn't a problem. We can still use the reverse power rule to find the antiderivative of this function. Simply, instead of 1, we're going to write that 1 is 3 over 3, because these two are equivalent. So when we're applying the reverse power rule, it will look like this. 2x to the 1/3 power plus 3 over 3 over 1 over 3 plus 3 over 3. Then we're going to simplify this, and it is going to become 2x to the 4 over 3 power over 4 over 3. Our next step is to simplify this as much as we can, and we're going to do that by doing keep, change, flip to divide the fractions. So this is going to become 2x to the 4 over 3 times 3 over 4, which is then going to become 6x to the 4 over 3 power over 4. Next, we're going to simplify this fraction by dividing by 2, and we're going to get 3x to the 4 over 3 power over 2. But we're not done. Remember what I said before. Every single time you apply the antiderivative, you always need to add a plus c. So the antiderivative of 2x to the 1/3 power is going to be equal to 3 over 2 x to the 4/3 power plus c. Another kind of problem you guys might encounter is one where the variable, x in this case, is in the bottom of the fraction. Now, to do this kind of antiderivative, there's several ways you can approach it. The way I would approach it is to bring up the x to the 5th power by making the exponent negative. So this integral is actually equivalent to the integral of 4 times x to the negative 5 power dx. Once we're here, we can simply apply the reverse power rule again. So we're going to do that. We're going to do 4x to the negative 5 power plus 1 over negative 5 plus 1. Next, we're going to simplify this so that it becomes 4x to the negative 4 power over negative 4. Then we're going to simplify this by canceling the 4's, and we're going to get that the integral, or the antiderivative, of 4 over x to the 5th power is equal to negative x to the negative 4 power plus c. And if we wanted to simplify this even further, we could say that this is also equal to negative 1 over x to the 4th power plus c. You might also run into a problem like this one, where you add. So in this case, you can simply apply the antiderivative to each term separately. So this is equivalent to the integral of x to 3 over 2, plus the integral of 10x, plus the integral of 6, and of course add dx to each of them. So when we do this, we're essentially just going to apply the reverse power rule to each term. So I'm going to arrange the start space to do that. So we're going to start with x to the 3 over 2 power. So we're going to write it down, and we're going to add 1 to the exponent. And then we're going to do it on the bottom as well. 3 over 2 plus 2 over 2. Then this is going to become x to the 5 over 2 power over 5 over 2. We're going to simplify this further by dividing the fraction, giving us that the antiderivative of x to the 3 over 2 power is 2 over 5 times x to the 5 over 2 power. But we're not done. We still have 2 more terms left. Now we're going to do the antiderivative of 10x. So we're going to write it down. Then we're going to, So we're going to write it down, and we're going to do the reverse power rule again. And we have a 1 on the x, and we're going to add another 1 to it. And we're going to do the same thing on the bottom. Then we're going to simplify it so that it becomes 10x to the 2nd over 2. And this is going to simplify to 5x squared. So the antiderivative of 10x is 5x squared. So we're going to add that to the bottom here, 5x squared. Finally, we need to do the antiderivative of 6. I'm going to do that over here. So the antiderivative of 6. So 6 doesn't have a variable in it. It's just a constant. So the antiderivative of 6 would simply be 6x, because the derivative of 6x is just the constant on the term, which is 6. So the antiderivative for this function right here is going to be 2 over 5 x to the 5 over 2 power plus 5x squared plus 6. But we can't forget the plus c. Now, I know what you guys might be thinking. Doesn't each term have its own plus c since I did the antiderivative separately? Well, yes, that is true. However, if you add one c to another c, you're simply going to get another c. So you can just add the plus c at the very end. So the antiderivative for this function will simply be this. So this is another kind of problem you guys might encounter while doing antiderivatives. A fraction where there is addition or subtraction in the numerator. Now, in order to solve this, we're going to do what we did in the previous problem, and we're going to separate it into multiple integrals. But before we do that, I want to convert the square root of x to powers because it's going to become easier. It's going to be easier to work with. So any root can be written as the x to the fraction where the numerator is the power of the variable, which in this case is 1, and the denominator is the index of the root, which in this case is 2. So the square root of x is actually equal to x to the 1/2 power. Now I'm going to divide this into two integrals. So it's the integral of x over x to the 1/2 power plus the integral of 3 over x to the 1/2. Now I'm going to simplify this further before applying the reverse power rule. When I'm dividing exponents, I can actually subtract them. So this part will simplify to the integral of x to the 1/2 power. On the right hand side, it isn't so easy, but we can still simplify it by raising it and making the exponent negative. So it will be the integral of 3 times x to the negative 1/2. Now we can apply the reverse power rule. So it's going to become x to the 1/2 plus 1 over 1/2 plus 1, which will simplify to x to the 3 over 2 over 3 over 2, which will later become 2 over 3 x to the 3 over 2 power. Now let's do the right side. So we're going to apply the reverse power rule, same as before. It's going to be 3x to the negative 1/2 plus 1 over negative 1/2 plus 1. And this will become 3x to the 1/2 power over 1/2, which when simplified will become 6x to the 1/2 power. So we're going to add that to this down here. 6x to the 1/2 power. Now, we're not done yet. Remember, we always have to add a c. So we're going to add the c, and that's how you do the antiderivative for this problem. Alright guys, so before I end this video off, I want to tell you guys that although the reverse power rule is an effective method for applying the antiderivative, it doesn't work all the time. So I'm going to give you guys an example where it doesn't work. So say I wanted you guys to find the integral of 5 over x dx. This actually cannot be done using the reverse power rule because the integral or the antiderivative of this function is actually 5 times the ln of x plus c. So the way I did that is I took out the 5 from the integral, and the antiderivative of 1 over x dx is ln of x. Now there are several formulas like this that you need to know, and I'll attach them at the end of the video. But essentially what I'm trying to say is that the reverse power formula will not work for trigonometric functions, logarithmic functions, or transcendental functions. So keep that in mind when doing the antiderivative for whatever function you're using.